Astronomers have cracked a mystery 1,000 light-years from Earth. In the spring of 2020, a group of astronomers told the world a dramatic story. They had discovered a black hole just 1,000 light-years away from Earth, closer to us than any they'd found before. They detected it in a constellation called Telescopium, nestled alongside two stars that, on a clear night in the southern hemisphere, are visible to the naked eye. On the scale of the Milky Way, it's in our backyard, Thomas Ravenius, the astronomer who led the new research, told me at the time. It turns out that the finding was just the first chapter, because there's been a major plot twist: the black hole doesn't actually exist. Ravenius and his colleagues were wrong. In Ravenius's defense, black holes are invisible. But they're also eternal and imposing and enormous, 4 times the mass of the Sun, in this case. How could this one turn out to be nothing at all? As with any good mystery, things aren't always what they seem. Also, more telescope observations really help. After Ravenius and his colleagues published their results, other groups of astronomers analyzed the data for themselves, a common response in science. One team of scientists thought the star system at the heart of Ravenius's research resembled another system that they had studied, which didn't have a black hole. They suggested a different interpretation of the data, explaining that those data didn't indicate the presence of a black hole, but of some intriguing activity between the two stars. Of all the alternative explanations, this was one that really got me sweating, because I realized that this is maybe a viable option. Ravenius, an astronomer at the European Southern Observatory in Chile, told me recently. The two teams agreed on one thing: they were looking at two very bright stars, and one of them was rotating quite rapidly. Ravenius's team thought that the stars orbited each other at a distance, and that the fast one got its speed by swinging around a black hole. The other team, led by Julia Bodensteiner, then an astrophysicist at KU Leuven, in Belgium, believed that the stars were much closer together, and that the fast rotating star was behaving that way because it had stripped away some material from its stellar companion, gaining a little boost. The telescope that Ravenius and his team had used wasn't capable of resolving the true distance between the stars, and, in turn, of allowing astronomers to figure out what was really going on, so the astronomers needed data from a different kind of instrument. Both teams started working on research proposals asking for time to use a telescope in Chile, the only facility in the world that could give them the sharp look they needed to decide between the competing scenarios. Eventually, they decided to team up. They were trying to observe the same target, after all. Plus, they'd already gotten over the awkwardness of having competing ideas. The community is small, Bodensteiner, who is now at the European Southern Observatory, told me. We knew everyone before, and one of the people from the other team actually supervised my master's thesis. When the data came back, the explanation from Bodensteiner's team won out. It turns out that Ravenius's group had captured the aftermath of a little stellar snacking. We think the two stars were happily orbiting each other until at some point, one of the stars transferred its outer layer, material from its atmosphere, to the second star, Bodensteiner said. In other words, the second star ate bits of the first star. This is a common phenomenon in star pairs, and when it happens, the transfer of mass from one star to the other makes the material swiping star spin more rapidly. The one-time snacking happened some time ago. Right now, nobody's eating anything from anyone, Bodensteiner said. Ravenius hadn't considered this scenario because the idea that his team could have captured this brief cosmic moment seems so unlikely. Scientists believe that such cosmic chomping is common in cozy, two-star systems, but the aftermath is short-lived. Snacking phases last just a few thousand years, and stars live for hundreds of millions, even billions, of years. Even if you have hundreds of such systems, or thousands of systems, you expect those stars to be either before that phase, or after that phase, Ravenius said. Now that the twist has been revealed, both teams plan to work together to monitor the binary star system as its own interesting scientific target, even though there's no flashy black hole. It's a cool result either way, but I'm happy that this scenario came out on top, just because there's a lot of stuff we can do now, Abigail Frost, an astrophysicist at KU Leuven who worked on the observations with Bodensteiner's team, told me. These stars can have quite important effects on galaxies and stellar systems as a whole. The case of the disappearing black hole shows just how difficult detecting these objects can be, even though they're everywhere in the universe. According to Bodensteiner, several discoveries announced in the past few years have faced some rebuttals. It's just incredibly difficult to find something that doesn't emit any light, she said. Astronomers usually have to get creative and look for black holes indirectly, in the movements of celestial objects or the glow of cosmic material around them. The biggest black holes in the universe can eject some forms of radiation, cosmic burps from eating the stars around them, but smaller ones, like the one Ravenius's team believed they had found, are much more difficult to uncover. The title of the nearest black hole to Earth, that we know of, can now be returned to a black hole that resides about 3,000 light-years away in the constellation Monoceros. Astronomers have found black holes closer in, about 1,500 light-years from Earth, but their existence has yet to be confirmed, Ravinius said. He suspects the real closest black hole is only a few hundred light-years away, tops. We just haven't found it yet.